Okay, in this video, we're going to look at estimating population size in a habitat. And it's important in evaluating the health of an ecosystem. Is an organism threatened or endangered? Is it in need of protection? Could there be predators overrunning the habitat? Should a population be thinned, as might be needed in some cases? All of these are important in environmental management. So the objective we're looking at is determining the population size using appropriate sampling methods. And we're just going to look at some of them. So population sampling methods for moving and non-moving objects. For example, quadrats and transects, which are for non-moving. Capture mark, recapture, which are for moving organisms. And of course, there are other methods as well, but these are the ones we're going to look at. So there are different means of measuring the size of population that depend on several factors. For example, if the organism is large or small, if the population is moving or non-moving, etc. And these methods include the use of transects and quadrats, and capture mark, recapture. So quadrats, what is a quadrat? Well, a quadrat is a kind of a empty frame, a bit like that. And you can put it down and estimate what's underneath it, as is shown here. And you do it in several parts in the ecosystem, and you count what's in it. And by taking a sample, we can extend that to the entire area under study. So first of all, you measure the area and form a grid. A bit like this, you form axes and you number them. Take two random numbers and use these as coordinates for the grid. So you can use a coordinate here and a coordinate here. And you lay down the quadrat down and count the number of species and record the results. And you must have a random assignment of grids. So we generate the numbers and the axes, therefore, using a random method. And this method is more scientific than simply throwing the quadrat from your bag. And of course, the bigger the sample, the better the validity. And sometimes you can cut a quadrat into segments, which means estimating cover is easier. So, going back to it then, how could we find out what plants are growing in this meadow? And counting every plant would take too long, as the meadow is very large. So what we do is take samples instead, and we use a quadrat to find the sample, to take samples. So how do you choose where to put the quadrat? And the important thing, this needs to be done randomly to avoid bias. And this technique is called random sampling. There's another type of sampling we're going to do in a minute. So the method, you place tape measures on the ground, forming an X and Y axis, here and here, and generate random coordinates using a calculator. I suppose a calculator can generate random numbers. Alternatively, you could put numbers into two separate hats and draw numbers from each hat. That will also generate random numbers. And place a quadrat on the ground at the first coordinate and record the plants that are present. and then you repeat for all the other coordinates. And you're going to do that several times. So the apparatus to use is a 50 cm by 50 cm quadrat, or half-meter quadrat. And this is placed on the ground, where it provides a small area where plants will be counted. You have tape measures to form the X and Y axis. And then you need an identification guide. This is to identify the different species of plant. You have a table of results for simply to record them. I need a calculator to generate random numbers. As I said, you can probably use a hat or a container and draw numbers out of each container. And you record the coordinates here, and then you have the number of daisies, dandelion, buttercup, and so on. There's another thing you can do, which is investigating how abiotic factors affect plant distribution. So random sampling is only carried out when you expect the area to be uniform. And sometimes there might be a change in abiotic factors. For example, moving away from a tree, or going up a mountain, or across a path. And in this case, you need to do a systematic sampling instead, to see how the plants may change across the area. So I suppose here you have coming away from the tree. The vegetation seems to have changed. Or going up a mountain, the vegetation has changed. Or going across a path. You can see here's a pathway. The vegetation on this side of the path seems to be different from this side of the path. But maybe after a time, the vegetation turns to more or less the same. So in this case, you place a tape measure on the ground going along the environmental gradient, such as away from the tree. So you place the transect here, going away from the tree. I suppose you could have it the other directions as well. And even going backwards. It seems the only way where there's a significant difference is this way. So you place a quadrat on the ground at 0 meters from the measure and record the plants in the quadrat. Also record the abiotic measurements in the quadrat. And you can measure, say, perhaps light intensity or humidity or things such as that. And repeat at set intervals, e.g. every meter, or every 2 meters or so on. And again, a list of the equipment you use and what it's used for. And again, how you tabulate the results. And an extension, some people do ecological sampling as their job. What might they find out? And how might this information be used? So it can be used to find new plants, assessing if plants are endangered, but to find their population size. Seeing how an area might have changed over time. This means assessing population size over time. And ecological surveys before and new buildings, how railways are built, etc. So you can find out what the ecological system is like before the new building is built. I suppose you can find out if the environment, the ecosystem is vulnerable and things such as that. Then percentage cover. Sometimes it's hard to count exactly how many plants there are in a quadrat if you have grasses, such as that. Counting all the grasses would be almost impossible. In this case, you can work out percentage cover, and that is the percentage of the area that is covered by a grass. So working out this one, how would we do this? Well, we have each square, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2. So you have 100 little squares. In this first small square, you probably have, each square, therefore, is 1% of the total. And this is probably less than half. So maybe about 0.2. And that is a 1, so 1.2. Also full, and 2.2. That's probably about 0.4, so 2.6, 3.6, 3.8, 4.5, and you go on that way. So percentage cover, 25 square means each square is worth 4%. Nothing in these. This is saying a quarter of this square is covered. That's why it's 1%. This one is 4%, assuming all of it is covered. This again, another quarter. This 3/4, that's why you have 3%. They just count all of them and have a percentage cover of 29%. And dividing it into small squares makes it easier to estimate that that is about 29%. How each square is worth 4%. So we'd have 4, 8, 12, 16, 20. Up to there, that's 40. That's probably 3/4. So that's 43%. 47. 51, 55, 59, 63, 67, 70, then what, 71, 71, 75, 79, maybe about 80, so that's maybe about 81%. And then we asked for these ones, is this random or systematic? I suppose if you're going away from the tree, then it will be random. If it's going away from the tree, it will be systematic. Otherwise, it will be random. I suppose in this case, it's hard to tell. You could perhaps try both of them. But the next one, systematic or random. Here we have a mountain, and there's a clear difference going up the slope. So using systematic. Well, that's sort of transect. You put a line down, which is a transect, and go up it and use quadrats. Or systematic or random. Here we just have a field, everything looks the same. So it's random. This one, counting seaweed of species up a beach. We're going up a beach and therefore there's a change. So it's going to be systematic. Estimating the number of orchids in a rainforest. expect it to be more or less the same, so it's going to be random. Now, so far we've looked at populations for plants. We can also look at it for animals. And what we do is use the capture-recapture method. So on day 1, you capture 10 individuals and mark them. And then on day 2, you capture some more individuals and find out how many were marked. And the population size of the number in the first sample, which in this case was 10, multiplied by the number in the second sample that was marked, which is 1, 2, 3, 4, 5. And then number in second sample. So number in second sample again is 10. And number in second sample that were previously marked, so this is 5. 1, 2, 3, 4, 5. So you have 10 times 10 divided by 5, which is 20. So half the individuals are marked, so half the population total. Therefore, the population is 20. Another method. We first of all capture some fish. Well, first of all, you capture some fish and mark them. You release them. You capture some more fish. And you find out the number that are marked. And you use the same formula. Number marked in first sample. Number marked in second sample. Divided by the number in second sample. Previously marked. So in the case of the this one is marked 1, 2, 3, 4, 5. We have number of tagged fish is 10 times 10 divided by 5, coming to 20 again. And this is an activity for you to do, where we get to a hat, put in the first hat piece of paper going from A to I, no, to J in fact, and then in the second hat numbers 1 to 10. And you pick one from each hat at random and return them, of course. And you're going to record the quadrat axes and identify the number of native grass, which is, and so on, in each quadrat, and find the average number per square meter. And then you multiply by 100 to get the total in the area. So while it's important to choose positions in the quadrats randomly, of course it's to eliminate bias. How do you decide if a plant was inside or outside the quadrat? If more than half of it is inside, you count it. Otherwise, you ignore it. If you're working in the field, how can you write other difficulties you encounter? Well, I suppose that difficulties you might actually encounter in the field. For example, if you have large trees, getting the quadrat around the large tree may prove difficult, for example. You can think about that. How would you ensure you didn't damage the environment you were surveying? Again, you can think about that. How do you think your results give an accurate picture of grass or that? Or do you think they give an accurate picture? If you look at these, one thing you can do is work out the total and compare it to the total that you estimated. using the quadrat to see if they correspond. And that more or less completes the discussion.